Hello class, today's lesson is over adding and subtracting fractions with unlike denominators. Before we begin, let's go over and review some of the vocabulary from last week. So first we have a fraction. Now a fraction is a part of a whole with all parts equivalent. Now the numerator is how many parts of the whole, which is the top number. So here we have 2 over 4. The numerator is number 2. Now the denominator is how many parts make up the whole, which is the bottom number. Here we have 4 over 4, so the denominator is 4. Now moving to the common denominator, which is one or more fractions that have the same denominator. This is necessary for adding and subtracting. So for example, 1 over 8 plus 2 over 8, and these two have the same common denominator, which here is number 8. For the least common multiple, which is the smallest common multiple of 2 or more denominators used to determine common denominators. So for example, multiples of 3, so they are 3, 6, 9, 12, 15. Now multiples of 5, these are 5, 10, 15, 20, and here we have the least common multiple, which is 15. Now let's move this out of the way. So for example, here we have 4 over 5 and then 2 over 5. So these two have the same bottom number. Here we have 4 over 5, 2 over 5. The same denominator here is number 5. So when two fractions have a common denominator, this means both wholes have been divided into the same number of equal pieces, and each piece is the same. Now in order to add fractions, the fractions must have the common denominator. These pieces of each fractions need to be the same to combine them together. Okay, let's say we have 2, now let's move this fraction. So let's say we have 2 over 7 and 3 over 7. Notice these two fractions have the same denominator, so the equal parts of the whole has been split into are the same size. Since the pieces are all the same size, we can add these two fractions together. Now if we're adding these two fractions with the common denominator, you can combine them together by adding the numerator together and the top number, which is the top number, and the denominator will always stay the same because the size of the equal pieces does not change when you combine the two fractions. Okay, so for example, let's say we have 1 over 10 plus 6 over 10. Notice they have the same denominator, so these can be combined together. So to add the numerator, we can add 1 plus 6 equals 7. So we keep the denominator the same, which is the bottom number, which stays 10. Remember, the denominator does not change because the size of the pieces stay the same. So here is a visual way to look at the same problem. So here's the 7 over 10. This is for the fraction. So for the first rule here, we have, this applies to this rule. So when the same two denominators are the same, this rule is applied. Here is the rule to adding fractions and the denominator are the same. So all you need to do is add the numerator and keep the denominator at the bottom will stay the same. Another general rule for adding for adding and subtraction fractions is this rule: adding subtraction fractions with common denominator. So first you add, subtract the number, you keep the denominator the same, and then you simplify it if you need it. So let me show you when we simplify it. Now let's take a few examples. Here we have 1 over 10 plus 7 over 10. So this equals, so 7 plus 1 equals 8. The denominator stays the same. Now to simplify, you can simplify this fraction. So what number can you use to simplify this fraction? So we can use 2. So we can divide each one by 2. So 8 divided by 2 equals 4. 10 divided by 2 equals 5. So that's it for that one. So now let's try with subtraction. So 7 over 12 minus 3 over 12 equals 7 minus 3 equals 4. And then the denominator stays the same. Okay, so what number can we divide? What number can go into this number to be divided? We can use number 4 divided by 4. So 4 divided by 4 equals 1. And then 12 divided by 4 equals 3. So that's for that one. Now we are moving to addition, subtraction, fractions with different denominators. Okay. So when two fractions have different denominators, that means that the wholes have been split into or not. Let me use this picture. Okay, so when the two fractions have been different denominators, this means that the two pieces of the whole have been split into but are not the same size. So we cannot combine them with addition or subtraction until we fix it by finding the common denominator. So let's take 2 out of 5 and 1/2. So notice the pieces are not the same size, so we cannot add them as they are. So there is more than one way to find a common denominator. We usually want the smallest possible number to use to make things easier. So we're looking for what's called the lowest common denominator. This is also called finding the least common multiple. So one way is to list the multiples. Dropped my marker. So one way is to list the multiples of each denominator that look for the smallest number. So let's take multiples. Take the multiples of 5. So we have 5, 10, 15, 20, and so on. We can always come back and add more multiples if we need to. Multiples. Now let's do multiples of 2. So it's 2, 4, 6, 8, and 10. So here we have this common multiple. The least common multiple is 10. Now the smallest multiple that the denominators have in common is 10, as we see here. So we can rewrite the two fractions using 10 as the common denominator. Okay, to do this, we have to make sure the multiples and denominator of fractions are the same. So let's do 2 over 5 and then 1/2. So we need to multiply this one by 2. So whatever you do to the top, the bottom you have to do to the top. So 5 times 2. I took the 2 because it's 1, 2, so it equals to 10. So 5 times 2 is 10. And then 2 times 2 equals 4. Now the 1/2, we took 1, 2, 3, 4, 5. It was 5. So 2 times 5 equals, I didn't put that equals 10. And then whatever you do the bottom, you have to do the top. So 1 times 5 equals 5. Okay, so once we have the fraction rewritten with the same denominator, you can combine them together. We can combine them now together when we add in the addition or subtraction. And in this case, it was